This is Math 270, section R.4, Slope and Linear Functions. The slope of a non-vertical line is a number that measures the line's steepness. We can calculate the slope by picking 2 points on the line and writing the ratio of the vertical change, called the rise, to the corresponding horizontal change, called the run, as we move from one point to the other. So slope can be represented in a numerous amount of ways. For number 2, we have, insert a little pointer here, slope is equal to m. So I don't know who decided that slope was going to be represented with the letter m, but that's what we use. And that is equal to rise over run, which is the equivalent of change in y over change in x. And we also think of it as vertical change over horizontal change. And the slope formula is m equals y2 minus y1 over x2 minus x1. So if we have 2 points on a line, we can calculate the slope and see how steep that line is. So for example, in number 4a, if we want to calculate slope, it's sometimes helpful, I'm going to zoom in if I can here. Okay, erase that. It's helpful to label the points. So this is, we'll call this x1 and y1, and we'll call this one x2 and y2. And we want to do that because we have this formula that says our slope is y2 minus y1 over x2 minus x1. Alright, so we just plug in the numbers that correspond with those variables. So that would be 5 minus 3 over 2 minus 1. And simplifying, we get 2 over 1, but that's not simplified enough. It's really just 2. Okay. Alright, we'll go over to example B and do the same procedure. So we have, I'm not going to put the whole formula out again, but I will label them x1, y1, x2, y2. So m is going to be 6, oops, excuse me. 2 minus 6 over 5 minus 3. Now if you did it the other way, it's okay. You can do 6 minus 2 over 3 minus 5. It doesn't matter, but if you're going to switch the top, you also have to switch the bottom. Alright, so that's negative 4 over negative 2. Okay. In the next example, we need to use the graph to determine slope at y-intercept and x-intercept and write the equation of the line. So there's a table here to help us along with this. So the slope is rise over run. So if I zoom in to this first graph here, what I'm looking for is, well, we find a point that's right on the grid. This point right here, 0, 5. So slope is telling me how far up and down compared to how far left and right I'm going. Well, I notice if I go up 1, I need to go over 1, 2, 3, 4 before I find another point on the grid. So my slope is rise over run, so I went up 1 and to the right 4. So you can see the line is going up from left to right. That means I do have a positive slope. So we'll just put 1/4 in here. Alright, now the y-intercept is where the graph crosses the x-axis. And we can see that that's happening at the point. Well, I better zoom in again here. 0, 5. Right, we can see that if I zoom in on the graph again, we can see that it's crossing the x-axis or the y-axis right here. That's our y-intercept. And the x-intercept is where it's crossing the x-axis. So we can't tell by looking at this picture where that's happening, but there's another way. We have enough information now actually to write the equation of this line. So it would be y is equal to 1/4 x plus 5. You just put in your slope and your y-intercept. So x-intercept is going to be where where the line crosses the x-axis. So x would be 0 in that case. So if we just plug 0 into this equation, or I'm sorry, y would be 0. So we want, when we're crossing the x-axis, y is 0. So it's 0 equals 1/4 x plus 5. And we subtract 5 on both sides. And then multiply by 4, we see that that's happening at x equals -20. So it would be -20, 0 for the x-intercept. Okay, and we'll go over to the other graph. This one we can see where the x and the y-intercept are pretty clearly. We have our x-intercept here at -6 and our y-intercept here at -2. So we can go ahead and fill that in. We'll get to slope in just a moment. So y-intercept, x will be 0, y is -2. For x-intercept, x is -6 and y is 0. So just to remember which one would be 0 and which would be the number, if you're talking y-intercept, then you should have a value in the y spot. If it's x-intercept, then there should be a value in the x spot as far as the ordered pair. You know, our ordered pairs are always x and y. So if you have x-intercept, then there should be a value for x. If you have y-intercept, then there should be a value for y. Okay. Oops. So let's go back and do the slope now. Alright, for slope, again, remember if you find a starting point, say right here at -6, and if I go down 2, and then to find my next point on the line, I'm right here at -2, so I went down 2 over 1, 2, 3, 4, 5, 6. So it's a negative this time. We're going down and to the right, -2 over 6. But notice that's the same as -1/3, because I could have taken a different route. Let me get a new color to do that. I could have gone down 1 and over 3. See, it doesn't matter if you pick the exact same one that I picked. We could have also gone, give me one more color, green. Could have gone down 3 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, which again 3 over 9 is the same, reduces to 1/3. So our slope is definitely -1/3 no matter how we look at it. Okay. The slope of horizontal lines are blank and slopes of vertical lines are blank. Well, if you have a horizontal line, and just to remind you, horizontal lines are like so, like this green line here. The slope is 0. It's not sloping up or down. It has no slope, essentially. So if it's horizontal, it has no slope, or we say 0 slope. Vertical lines are the ones that are going up and down, like so. And those are actually undefined slopes. And the reason they're undefined is what happens is you'll end up with 0 in the denominator if you try to pick 2 points and find the slope on a vertical line. So if you have 0 in the denominator, as you remember, that means that it's undefined. Okay, next. Graphing horizontal and vertical lines, well, I've done that a little bit already, but we can do some more. If I want to graph y equals 5, I should recognize first that that's a horizontal line, and you're gonna locate y equals 5 on the graph, which is right here. This is where y equals 5, and then just draw a horizontal line through it. Mine's a little crooked, but you get the idea. And now if we're going to do something like x equals -4, it's almost the same procedure, but in this case we're going on the x-axis, finding -4, and then drawing a vertical line through it. So x equals a number is a vertical graph. The slope-intercept form of an equation of a line is y equals mx plus b, where m is a constant representing the slope of a line and b is a constant representing the y-intercept of a line. So find the slope and the y-intercept of the line with a given equation. Well, part A, it's quite easy because it's in the right form already. So I just pull the information from here. M equals 2, it's the number in front of x, and b equals 8. It's the number not in front of x. B, however, involves a little bit of manipulation. We need to first solve this for y, so I'm going to add 5x to both sides, and that gives me y equals, and we generally write the x term first, 5x plus 4. So again, if I just pull the number in front of x, that's 5, that's the slope, and the y-intercept is the other number, 4. Find the equation of a line with the y-intercept and slope given. So we just take the information given to us and write the equation. So this is 2x plus 5. This one will be -3x plus 3/5. And the last one, oh, there's 2 more, just kidding. C is going to be y equals 1/4 x minus 12, and D, y equals 4x. We don't write plus 0, we just leave it off altogether, and that's implied that it's plus 0, that our y-intercept is 0. Find the point slope form of equation of a line. This is useful in some applications. So it's a different equation. It's a little slightly different equation than the slope-intercept form. It's basically if you take the slope formula and move this y minus y1 over to the other side, you get the point slope form of equation. So you can use this to find the equation of a line. If I'm told that the slope is 4 and I might have the point 1,3, notice that 1,3 is not a y-intercept. So I can't do like I did in the previous example where I just say y equals 4x plus 3, because 1,3 is not the y-intercept. Okay, this thing I'm pointing to, not the y-intercept. So instead we use the point slope form when we're in that situation. So it would be y minus the y value, which in this case is 3, equals 4 times x minus the x value, which is 1. And that's really all you have to do. You can solve it for y. So I'll go through this time and solve it for y, but you don't, at this level, that's not really necessary. So we add 3 to both sides, and then finally we get y equals 4x minus 1. So you'll notice that the y-intercept was -1, not 3. This other one, I'm ready for a new color here. Let's see what we can find. Something interesting. The greens don't really get that dark. Maybe a little lighter. Yeah, let's try that. So y minus the y value equals -2 times x minus the x value. So that's really y plus 12 equals -2x. And this minus a minus is a plus, so that'll be -22 once you multiply it by the -2. Subtract the 12 on both sides. And what we end up with is y equals -2x minus 34. Okay. Find the equation of a line given 2 points. Find the slope and use the point slope formula to find the equation of the line in standard form. Okay. We haven't really talked about standard form. So we'll just put it in the slope-intercept form. Standard form is technically this, ax plus by equals c. So I don't think that's going to come up in your homework, but if it does, let me know. It's not that hard to get to. Once you solve it for y and put it in slope-intercept form, what you do is just make sure the x and the y terms are on the same side, and the c and the number by itself is over on one side by itself. Alright, let's look at this first one. Zoom in, good. We're going to use the slope formula again to get the slope. So m is equal to 8 minus 6 over 8 minus 2 over 8 minus 6. Alright, so that's 6 over 2, which is 3. And we don't have a y-intercept here, so I'm going to go ahead and use the slope, the point slope formula. So that's y minus 2. I'm going to use the first point, doesn't matter which one you use, equals 3 times x minus 6. So notice that I used the 6, which goes with the 2. I could have used the 8s, 8 and 8, or 6 and 2. You just can't mix and match them. So y minus 2 equals 3x minus 18. And then we add the 2 to both sides, and we get 3x minus 16. And just in case you need it, the standard form would look like this. You would subtract 3x over. You have 3x plus y equals -16. So this is standard form. There's 3 forms that we learn along our algebra career. So this is slope-intercept form. And back here, this one that I'm putting a squiggly line around, that one is point slope. All right, example B. Again, we want to start with the slope, so m is equal to -5 minus 0 over -2 minus a -4. So it's a -5 in the numerator and a +2 in the denominator. So we pick one point. I'm going to, again, just pick the first one. Doesn't matter. And plug that in. So that's y minus y1, which is 0, equals my slope times x minus x1, which is -4. And this is convenient because y minus 0 is just y, and then I distribute this -5 halves in. Again, this double negative equates to a plus, and then -5 halves times +4 is going to equal a -10. Okay. We have a word problem, nothing too terrible. Boxowitz Inc., a computer firm, is planning to sell a new graphing calculator. For the first year, the fixed costs for setting up a new production line are $100,000. The variable costs for producing each calculator are estimated at $20. The sales department projects that 150,000 calculators can be sold during the first year at a price of $45 each. Find and graph C of X, which is the total cost of producing X calculators. Okay, so our C of X is our total cost of producing. Now it says that you have to, it's going to cost them, they have fixed costs of $100,000. That's before they even produce. They don't produce anything. They're still going to have to pay $100,000. So that $100,000 is your Y-intercept. That's your B. B is generally your fixed cost, and then your variable cost is what your slope would be, your M, and that's 20 times however many you're producing, which is X. So 20X plus 100,000. It also says to graph it, and I didn't leave a whole lot of room for that, but we can still do it. So the graph is going to look like so. We have an x-axis and here's C of X, your cost, and here's your X. Remember, C of X is just function notation. It's the same as Y. So your cost, if we put $100,000 right here, remember that's when X is 0, you still have a cost of $100,000. And then we're just sketching this, so it has a slope of 20 that's pretty high. And it's going up. So that's just a rough sketch of that. Part B, find and graph R of X, which is the total revenue from the sale of X calculators. Okay. And we're going to use the same axes. Alright, R of X then is our revenue, and it says that they think they're going to sell 150,000 calculators at a price of $45 each. So your revenue is just going to be 45 times however many calculators you sell. If you don't sell any, then you don't have any revenue, right? So if I graph my revenue up here, it's just going to start at 0. I have to clip the pen back. And it has an even steeper slope than the, oops, let me try that again. That was the curviest line I've ever seen. Not quite. Come on. there we go. Here's your R of x, starting at 0 and going up even steeper. Alright, using the same axes, find and graph P of x, which is the total profit. So this is something that you might need to recall, that your profit, your P of x, is going to be your revenue, how much you bring in, minus how much everything costs. So if we just substitute what we have in the previous two parts, revenue is 45x and our cost is 20x plus 100,000. And of course that simplifies. So that's going to be equal to 25x minus 100,000. All right. Oh, and we're supposed to graph that one too. Alright, well that means that we need to extend this graph because we want to start now at negative 100,000. That's this one's Y-intercept. I'll put it in green here. And then it had a fairly good slope of $45,000. 25 was the slope there. So it's just a rough sketch, like I said, but you get the idea. You can see that, you get a visual with what's going on. Alright, what profit or loss will the firm realize if the expected sale of 150,000 calculators occurs? So this isn't too bad. It's just a matter of taking 150,000 and you're going to plug that in for X in your profit formula. So it's 25 times 150,000 minus 100,000. So we're going to make a profit or loss. Well, a quick check in your calculator, you see that that's actually $3,650,000. So that's definitely a profit. We got a positive number. That's good. If this was your business, you'd be very happy about that. Final question here. How many calculators must the firm sell in order to break even? Alright, so in this case, we want well, you wouldn't necessarily want this as a business owner, but if you set your cost formula equal to your revenue, yeah. Then we can figure out how many calculators, we can figure out what X is and figure out how many calculators it would take to break even. Alright, so the cost function was the 20, let me go back up here so I can see, 20x plus 100,000. And revenue, that was 45x. So just a pretty simple algebra problem to do. Subtract 20x on both sides. We get 100,000 equals 25x. And if we divided both sides by 25, you see that you get 4,000. So they only need to sell 4,000 calculators to break even. They project 150,000 calculators, so even if they don't quite make that, they should still make a profit. Alright, that's it for R4.